Okay, we've got another question in context where we've got to combine normal distributions. So we're buying pick and mix sweets. Initially we're putting some sweets in the bag, and I've got the mean and the standard deviation of that. But then some of the sweets are being put back. So we've got a subtraction on our hands, and I've got the mean and variance of that. So that 30 is a standard deviation, but this 100 is a variance. So I'm going to, in part A, I'm going to set up my random variable. So that's going to be the weight of sweets that were put into the bag, and then the mum took some out. So we are taking V away from W. Okay, so I need to get the expectation of W minus V, and the means work the way you'd expect. So that's the expectation of W minus the expectation of V, and the expectation of W is 250 and of V is 120. So it's 250 minus 120, which is 130. And then I've got to do the variance of W minus V. Now, variances you have to think about a little bit more. Yes, it's the variance of W. Yes, it's the variance of V. But when we're subtracting the random variables, we still add the variances. So the variance for W is 30 was the standard deviation, so it's 30 squared. And the variance of the other one is 100. So 30 squared, which is 90 plus 100. Don't need a calculator, that's 190. So I've got that X is a normal distribution. Okay, and it's got mean 130 and it's got variance 190. Okay, so I'm going to be working with a mu and a sigma value. So my mu is 130 for this distribution, and my sigma variance is 190. So sigma, the standard deviation, is the square root of 190. Now I've got to get the probability of the bag containing more than 150 grams of sweets. So I do my normal distribution picture. Okay, this is the picture for the distribution of X. So with a Z value of 0 in the middle, I've got the mean, which is 130. And I want to be more than 150. So 150 will be this side. So 150. What Z value goes with that? And I want to be more than that. So that's what I'll be shading. So let's get that Z value. So Z equals X minus mu over sigma. So my X value is this 150. So 150 minus mu, which is 130, divided by sigma, which is root 190. And my calculator, when I do that calculation, gives me 1.451. And looking at my sketch, I can see that this 1.451, yes, that's good. It's a positive Z value, but I want to be above that. So I'm going to use that as the lower bound, and I'm going to go up to a high positive value. So I'm going to go into normal CD, and my lower bound is that 1.451, and my upper bound is going to be something large and positive, and I'm going to get my probability of 0.07339. And that's my answer for part A. Okay. All right, now I'm going to do part B. Now in part B, I'm paying for these sweets. So this is the X, this distribution here was the weight in grams of sweets in the bag. Okay, but now I'm paying £10 per kilogram. So this is a weight in grams, and I'm paying £10 per kilogram. So I'm going to therefore have to take the weight in grams and divide it by 1,000 to turn it into kilograms, and then multiply that by 10. Or I could just divide this by 100, because that's those two things taken together. So I've got to do X divided by 100, okay, and then I'm going to have to add on her other purchases, which is another distribution, okay. So I need to set up this other distribution. So let's call this second amount Y. So Y is going to be the normal distribution with mean £2.50, okay, and standard deviation 97p. So okay, that's 0.97 squared is the variance. Okay, so I'm going to be adding that to my X over 100. So in part B, right, so part B, I'm thinking about 1 over 100, 100th of X, okay, and I'm adding on Y, So that's a random variable. This is the cost of the X grams of sweets. So I've divided by 1,000 and multiplied by £10 because it's £10 a kilogram. And then I'm going to add on the Y. So I need the expectation of that. So the expectation of 100th X plus Y, that one's straightforward. It's going to be 100th of the expectation of X plus the expectation of Y. Okay, so the expectation of X was 130, 100th of that is 1.3, plus the expectation of Y, so there's the expectation of Y, which is 2.50, 2.50, so I'm going to get an answer of 3.80. Okay, so that's my mean. Now the variance of 1 over 100 X plus Y, okay, the variance I have to remember that I have to do 1 over 100 squared times the variance of X, and then I add on the variance of Y. Okay, so the variance of X was 190, so I need to do 1 over 100 squared times the 190, and I need to add on the 0.97 squared. So entering that calculation exactly as I wrote it, entering it on the calculator, it will give me this answer here. That fraction is 0.9599. There it is. So I've got a variance and I've got a mean. So therefore the normal distribution I need is going to have the mean, which was 3.80, and that value I've just worked out for the variance, which is 0.9599. So mu equals 3.8, and sigma is the square root of 0.9599. So I've now got to do the probability calculation. I want the probability of being more than £4.50. So diagram. Got a normal distribution. The value in the middle with a z-score of 0 is 3.8. But I want to be more than 4.5 is £4.50. So I'm going to get a positive z value, and I want to spend more than that. So I want this area here. So my z value is going to be the x value 4.5 minus the mean 3.8 divided by the square root of 0.9599, which gives me a value of, here we go, 0.7145. Okay, so that's my z value. I can see that on my normal probability, that's the lower bound, and the upper bound is a large positive number. So on my normal CD, lower bound is 0.7145, and the upper bound is something like 999 will do, and I get my p-value is 0.2375, and I am done. So there's the solution in full for part A of the question, and there is the full solution for part B.